Welcome everyone to an exciting webinar on computer vision with Cloudera. I'm Marc Chalà, and I'm thrilled to be your host for this event. Today we have a compelling topic to discuss, our very own Cloudera Image Warehouse. This framework empowers users to manage end-to-end computer vision use cases within Cloudera. Imagine harnessing the power of Cloudera Data Platform to create real-time image classification models using advanced convolutional neural networks. That's exactly what our Cloudera Image Warehouse empowers you to do. Now let's get to the heart of the matter. I'm excited to introduce Valerio Di Matteo, head of our Cloudera practice. Valerio will take us on an engaging journey through the world of computer vision, showcasing the incredible possibilities within Cloudera. Please join me in giving a warm virtual welcome to Valerio as we delve into this exceptional webinar on computer vision with Cloudera.
Hello everybody, thank you for joining us. I'm Valerio Di Matteo, Big Data Manager at ClearPeaks, and today I will talk about Cloudera Image Warehouse. So, what is Cloudera Image Warehouse? Cloudera Image Warehouse is a solution that we have recently developed to tackle one of the prime machine learning use cases across multiple industries today, which is computer vision. Computer vision, as many of you might know, is a field of study that involves enabling machines to interpret and understand visual data from the world around them. Typically, it's done through a specific class of machine learning algorithms called Convolutional Neural Networks, or CNNs. We'll get into the details of CNNs in a couple of minutes, but essentially they are a deep learning algorithm that, with a series of interconnected layers, tries to simulate how our own brain processes images. There are many very interesting applications of computer vision today, starting from facial recognition to self-driving vehicles, also medical imaging for early detection of diseases, object detection to classify objects or animals, and virtual reality and even art. Now, originally, we built Cloudera Image Warehouse for object detection. Specifically, our case was based on a heavy machinery warehouse, which operators and inspectors had to quickly scan mechanical pieces in order to identify broken or faulty parts and automatically process this information to optimize both time and costs of the purchase of the new parts. So imagine something like a big airplane factory or any other warehouse in which tens of thousands of different parts can be broken or acquired. Even assuming that the person will know all of them, and that's already hard, the simple action of selecting and labeling each one of them will be time consuming. So that's, for example, where our solution steps in. Now, for this example, we are not going to use the exact same case, but to keep it simple, we opted for a similar and much more familiar case in which we use a very well-known sample dataset, Cypher10, and we build an object detection model on it to distinguish between cats, dogs, airplanes, and so on, instead of thousands of different mechanical parts. So Cypher10 comprises of 60,000 32 by 32-bit images, and in this slide on the left, you can see that we take those images, we feed them to a Python code to train the CNN model, and then we use this model to predict other similar images, like the one on the bottom, obtaining the hopefully correct classification among, for example, the ones that you see on the right: airplane, automobiles, bear, cats, dogs, and so on. Just to explain a bit more about the convolutional neural network, here's a simple representation of how they work. They consist of multiple layers, each of which performs specific operations on the input data, but mainly we have three groups of layers. First one is the input layer, where the CNN takes the raw input image. Then we have the hidden layers, where the actual processing of the image happens. Typically, they are the convolutional layer, ReLU layer, pooling layer, and fully connected layer. Now, in these layers, techniques such as filtering, feature detection, dimensionality reduction, weighting, feature vector generation, activation functions, all of these are applied in order for the final layer, called output layer, to be able to produce the final classification or prediction. Again, as you can see on the right, for instance, in this case, we have a dog. Moving to the architecture, all the main components are represented on the slide. As you can see, all of our solution is based on the Cloudera stack. We have components such as Cloudera Machine Learning, Cloudera Flow Management, Data Visualization, and we'll go through all of them in a minute, but just to highlight what was the beauty of this exercise, we were able to build our full solution using different pieces of what is ultimately the same technology, Cloudera, without having to rely on multiple vendors and complex integration. Also, everything that we did was done on a CDP public cloud instance, but could be done on-prem or using one of the Cloudera data services or even a hybrid solution, thanks to the fact that all of the components that we used are available in the different versions, or as Cloudera calls them, form factors of CDP. So CDP private cloud, CDP public cloud, or Cloudera data services. Now, to go a bit more in the details of this architecture, on the top left, we can see the Cypher10 dataset, which we already mentioned, that we fed to a CNN algorithm running in Cloudera Data Science Workbench, or CDSW, which is nothing but the original version of Cloudera Machine Learning, or CML. So today, as I said, you could run CDSW in the cloud like we did, or on-prem, or you could be running CML as an auto-scaling data service in your Kubernetes cluster. Again, both in the cloud or on-prem, but nothing will change from the code or functionality perspective. Ultimately, after training the model, what you will obtain in any case is an API endpoint, which you can call from anywhere to obtain the classification or the prediction of a new image. Right below, we can see how a user would attempt such classification, for example, by sending the image via a web app or a mobile app, or like we do in our demo in a couple of minutes, by using Postman in the laptop. This image is sent to a flow in Cloudera Flow Management, also called CFM, or more simply NiFi, which listens to a particular HTTP request, stores the image in HDFS, enriches it with some metadata, and then simply calls the CML endpoint that we previously created. This call will return the result of the classification along with other useful information, and that's it. Nothing more is required to make our prediction. What the NiFi flow does next is to store all the data collected in different storage layers like HBase, Solar, or Kudu, and then these layers are connected to data visualization, which is another Cloudera app, where we build a simple dashboard to visualize all the information neatly. Again, just like for CML, all of this was done in a CDP public cloud instance, but both CFM and DataVis are also available on-prem or as a data service, and the storage layers can be pretty much anywhere you want. So effectively, this same architecture can completely be moved to an on-prem cluster, an auto-scaling deployment, or in a hybrid environment without any substantial change. Now, with that said, we can jump to the demo where we will see our solution in action. So here's our CDSW homepage. This is running in a CDP public cluster, but as we said, it could be on-prem or as a data service under the name of CML, and it will look pretty much the same in any case. As you can see, we have some information about our environment here with running session, models, and so on, a view of our physical resources, and right in the middle of the page, we have our project. Now, the project that we want to look at today is computer vision POC, and if we open it, we can see all the files that make up the project. And in particular, we can open the file containing the CNN model that we built for this case. If we scroll down at the bottom, we can see how the model is actually saved in CDSW as a model file called CNN for epochs. And if we wanted to try our code, we can do so by opening up a session in the workbench by clicking on the button that is right in the top right corner. Here, we give our session a name, we set up some session properties, such as the kernel, the specific Python version, and we assign the desired resource profile. Now we can start our session, and what is happening here is that a secure Docker container is being created, pods are being initialized, and then the environment is eventually ready. We can see now that on the left side, we have an editor with the code from which we started our session, and on the right side we have the output pane and an interactive console at the bottom. Of course, we can also test our code by running specific lines and see the output being displayed in the right side of the screen. For example, we can open another file in our project, select a few lines, click on run, and these commands are executed and their output is displayed for us to easily review it. In this session, we also have terminal access to the actual pod being run. For example, as you can see, we can open up a terminal to the pod and check details such as the Kerberos credentials, or for example, we could see the list of packages that are actually installed as part of this image. For example, as I am doing right now in the screen with this pip list command. Now, back to our file. This is actually where we wrote the code of the model that makes the prediction and returns its result. As you can see, it's executing multiple steps. First of all, we load the model that we saved, and we pass an HDFS location where we store the image to be predicted. Then we start a Spark session, which reads the actual image and does some pre-processing, applying steps such as rescaling, reshaping the image, and at the end, we run the actual prediction algorithm by calling the predict function of the model, and we finally return the result. But how is this model deployed? On the screen here, you can see that in CDSW or CML, we have a model pane where we can display and manage all the models that we deployed so far. For each of these models, we get an API endpoint, as we said, which we can in turn call from any other application, like NiFi in our case, and we get the output of the model back. Our model is already created, but to show you how to create a new one, we can click on the new model, we assign a name and a description, we select the file from the project which contains the function that we want to invoke when the model is run. Then we specify the name of the function, we select the runtime properties, such as the Python kernel, and finally we pick the desired resource profile. And we can even select the number of replicas that we want to deploy for high availability of our model. By clicking on deploy, our model will be created, we will get our API endpoint, and we will be able to invoke it from NiFi or from anywhere else. Let's now jump to our NiFi flow. As we can see on the screen, we have four main parts. The first part is to handle the incoming requests. This is where NiFi receives incoming images to be classified either from mobile apps, web apps, or any other tool like Postman, for instance. The image is then sent to the second block, where some pre-processing happens. We attach some metadata to the image, for example, timestamps and source IPs, and then we store it in HDFS. From there, we move to the third block, which is where the prediction actually happens. The request for the CDSW model we just saw is built using the HDFS location we just saved our image in, and then the model is invoked. Once a response is received, we move to the fourth and final block where the final information is stored in different layers. In this case, for example, Solr and Kudu. As you can see, we already have a request in the queue ready to be sent to CDSW. So let's stop the final process groups for a moment so that we can see the request actually traveling into the flow. Now we're going to start the process group that sends the request to the CDSW model, and if we refresh, we already see that we have a response there available for us to be explored. Now we can close NiFi and move to Hue, where we can see the Kudu table where we are storing our prediction results. Let's first run a quick select to see the current content of the table. We can see that we have 85 existing predictions. Now we go back to NiFi and we restart the final process groups, especially the one that is related to Kudu. And once it's started, we go back to Hue, we run our query once again, and we should be seeing a new record appearing at the bottom. Scroll down again, and in fact, we have 86 records now, meaning our new prediction was successfully stored. Now, to conclude the demo, we can go to the data visualization dashboard. As you can see, there is a total number of predictions on the top left. It already changed from 85 to 86. In the rest of the dashboard, we can see all the latest information about our predictions, all of which is backed by our Kudu and Solr tables that we just saw we populate at the end of the NiFi flow. For example, we can see the trends, we can see also the values of the predictions, and right below we can see the details of the requests and much more charts at the bottom. Now that our demo is over, we can draw some conclusions. First of all, we saw how we got a successful prediction. That's the first important fact. Then we saw how CML or CDSW gives us an API to easily integrate the model in any software or application that you have. Doesn't matter if it's from Cloudera or not. It also offers easy UI to operationalize the models. You saw how easy it was to create a new project, to navigate the project, and to actually create a new model, save it, and so on. Then we saw how NiFi is a very good choice to control the whole execution, because it is very easy to integrate with CDSW thanks to the API that the model offers, and also it natively connects to any of the Cloudera tools. But not only that, you can use NiFi to connect to virtually any other source or target that you might have in your architecture. We saw how it is easy to store the results of our application, of our prediction, anywhere. Again, we use Kudu, we use Solar, it could have been anything else. We also pass through HDFS during the flow. Literally there you can use whatever system you might want to choose for the prediction to be stored. Then we saw how we were able to visualize the results in a real-time dashboard. Again, we used Cloudera Data Visualization because it offers us an easy way to integrate with the Cloudera tools. And also you saw how the dashboard was updating live, and everything was, most importantly, under one single platform that could have run on-premise. For us, it ran on the cloud, but it could also run on a hybrid system. So that was the beauty of doing everything with the Cloudera Data Platform without having to rely necessarily on other or different tools to perform the tasks that we had to perform.
So this was Cloudera Image Warehouse, the solution that we developed at ClearPeaks. Before we conclude, let's take a step backward and recap what we talked about today. We talked about computer vision, one of the more predominant fields of AI today, with many applications across multiple industries. We talked about Cloudera CDP, the platform of our choice to deliver this end-to-end use case in any private, public, or hybrid cloud. And of course, we talked about our framework, Cloudera Image Warehouse, which, though it was developed for the aerospace industry, can be adapted to many end-to-end computer vision use cases. And when I say many, I really mean many. There's just plenty to pick. As you can see, many industries are covered. There's oil and gas with drill-static analysis, inventory tracking in logistics, quality control in manufacturing, predictive maintenance, pretty much everywhere, property valuation in real estate, so on and so forth.
Just for everyone, thanks so much for attending today. It was a pleasure to just basically share all this image warehouse under Cloudera knowledge with you. Any question, please let us know, ping us, email us. Thanks so much. Thank you.
Thank you, everybody.